Hi everybody, thanks for tuning in. In this video, I will show you how I made my Camber tool adapter. It made a quick appearance in my alignment video, so if you haven't seen that video, you should check it out because there's a lot of information that you might find useful. Now, for those that did see the Camber tool and was like, what is that? It's my solution to not having the perfect tool for the job. I purchased a tool that won't fit out of the box for me. And to be fair, it's not the tool's fault, it's my fault. The problem is that the tool is magnetic, and my rims and center cap are not. So as it came out the box, it would not give me an accurate or consistent camber measurement. Now I have used this style of tool before, but never on this vehicle with this setup. With or without the magnet, the tool needs to be mounted on a flat surface where the plane of that surface matches the plane of the wheel hub face or wheel mounting surface. This is the plane where camber angle is referenced. Now understanding that lets me know what part or components I can use to measure camber. The hub face, the brake disc mounting surface, and axle end or the axle nuts are popular choices when the wheel is off. When the wheel is on, the wheel rim face or rim lip may be used as a reference as well. So in my situation, I have about 3 options to get this tool to work. The first, I can take the wheels off and set the suspension up to ride height using jacks. Then I'll measure the camber at any of my wheel off locations. This will have to be done every time I want to check my camber. The second option is to convert my hubs to center locking units, which means I would have a single lug nut for each wheel, and to be completely honest, that would be badass. But between the hub conversion and buying a single hub wheel sets, I'm pretty sure it would cost me more than the cost of my car. So we have option 3. Make a custom adapter that doesn't require disassembly and won't break the bank. Obviously, option 3 was the most fun and affordable option for me. Now, if anybody wants to fund my center locking hub conversion, feel free to contact me. I'm here all day. So to make the tool, I have to contemplate its design and function. I could use a CNC machine or 3D printer to make a very nice, precise tool, but I chose to use a 2-part polyurethane casting resin. It's a relatively easy to use resin that is great for making cheap, high resolution molds, and I'll put a link in the description so you can know what I used. Its hardness rating is 75H, so it's hard enough to where it won't flex, but it shouldn't scratch the rim surface while I'm using it. It is machinable, but I have a full-size spare, so I'm going to make a mold from that spare. Theoretically, the camber tool can be placed on the rim's face surface because that plane should match the camber angle plane. But for simplicity and consistency, I want the tool to reference the wheel center and be self-centering. The important geometry for this to work is where the rim face and recessed lug area meet. This is where I can match the camber plane and implement the self-centering characteristic for the tool. All the geometry below that line isn't critical for measuring, but I do have to make sure that there's enough clearance so the lugs and center cap doesn't cause any interference problems. Okay, now let's get to the fun part, making the tool. The casting resin cures in about 2.5 minutes and reaches about 180 degrees Fahrenheit. It has an exothermic reaction. So if you do this, make sure you wear gloves and safety glasses. Then you want to test and confirm the materials you used for your mold geometry can withstand that type of environment, chemically and physically. I made 2.5 adapters. I used similar methods with a little variation for each. I set the wheel level so when the polyurethane cures, it'll be as flat as possible. Okay, so let's start with a half tool. For this, I use packing tape to line the surface and try to create a space for the lugs. The black material on top is sticky tape, usually used to seal door cards and light fixtures such as taillights. The failure came from me trying to use foam board to create the clearance for the center cap. I didn't secure it well. The foam board actually worked on other products that I've used it for. What happened in the middle of curing, it started to float. And me being aware of that, I tried to pull it out and the semi-solid polymer it did its thing. It froze right where it was. So if you have a failure or a small leak, it's probably best to just let it cure. Yeah. For the second tool, I used the same materials as the first, but I coated the tape with parting wax. Parting wax makes it easier to release the mold. It seemed to react with the resin, which is why it has that white coloring on the surface, but it doesn't seem to affect the geometry. It's just an aesthetic flaw. I decided to Dremel the clearances for the lugs, and I sanded the clearance for the center cap. And this tool came out okay. I mean, it actually works. To locate the center, I marked the mold while it was still in the rim, using the rim geometry measurements that I used in the alignment video. This is the actual tool that I show in the alignment video. For the third part, I used modeling clay. No tape, no sticky tape, no parting wax. The rim finish didn't seem to be affected by the chemical, so I would say that this is the best choice for me. And here's my disclaimer. My method may not work with what you have. You always want to test for reactions on a small hidden area or a similar material or surface. This part came out the cleanest and used the least amount of resin. The center point was marked in the clay with a razor, so I'm really happy with the resolution of the resin. I did trim off the sections that covered the lug pattern because they aren't really necessary for structural integrity. Originally, I wanted to keep everything solid because I was worried about flexing, but the polyurethane is stiff enough where I don't have to worry about that. And also there's enough clearance to rotate the tool so I can level it during use. To mount the tool, I did have to source a longer bolt because of the thickness of the adapter. To ensure the tool is accurate, I have to zero the tool once it's mounted to the adapter. This camera tool has an adjustable 0 point. I used another level to zero the tool. After that, the tool is good to go. So looking back at this project, there are some notes that I want to share with you. The resin is affordable, but it's not cheap, so saving it is a bonus. Measuring the volume of the space the resin needs to fill and using a gram scale for mixing the resin would improve my efficiency in making the part. The modeling clay was less than $15 for 5 pounds, and I was able to recover about 99% of it after using it, so that's a flat out win. I did wish I used sculpting tools to shape the clay instead of my hands. Using tools to shape the clay would make the part come out cleaner, and I wouldn't have to cut or sand as much. But hindsight is always 20/20, and this is why we have to reflect on the things that we do. Where there is space to improve, we work towards that improvement. I hope in thinking of ways you can use this resin, you really use your imagination. Materials or tools like this really open opportunities for creation. So if there's something that is good, challenge yourself to make it better. There's victory in failing because you can learn from your failures. And try your best to learn something new every day. So with that being said, stay tuned and thanks for watching.